Analyze the chemical equation and colors of the species. The equilibrium is represented by the equation. N2O4 is in equilibrium with number 2 according to the given information. Reactant N2O4 is colorless, and product number 2 is brown. Interpret the physical observation. When the equilibrium mixture is placed in an ice bath, the temperature of the system is lowered. The contents of the tube turn a lighter color, which indicates that the concentration of the brown gas, number 2, has decreased, while the concentration of the colorless gas, N2O4, has increased. This means the decrease in temperature has caused the equilibrium to shift to the left toward the reactants. Apply Le Chatelier's principle for temperature changes. Le Chatelier's principle states that a system at equilibrium will shift to counteract any imposed change. When a system is cooled, heat is removed. The equilibrium will shift in the direction that produces heat, the exothermic direction, to raise the temperature back up. Since cooling the tube causes a shift to the left, the reverse reaction must be exothermic. N2O4 is in equilibrium with number 2 plus heat. Identify the thermodynamic nature of the forward reaction. If the reverse reaction is exothermic, releases heat, the forward reaction must be endothermic, absorbs heat, delta H greater than 0. Heat plus N2O4 is in equilibrium with number 2 for this endothermic system. Cooling, removing heat, pulls the equilibrium to the left, decreasing the brown number 2 and making the tube look lighter. Conclude. The observation that the mixture turns lighter in an ice bath is explained by the fact that the forward reaction is endothermic, confirming option B is correct. The correct answer is option B. The forward reaction is endothermic.